Hi, geometry students. This is Mrs. Payne. We're going to start doing section 2.5 today. As you can see, the title is Proving Statements About Segments and Angles. So this is actually going to be using some of the stuff that we learned earlier in chapter 1, like the segment addition postulate and the angle addition postulate. We've already done algebraic proofs. Now we're going to officially take notes on how to do a geometric proof. So this is what you're supposed to learn. Write two-column proofs, name and prove properties of congruence. If you'd like to follow along in your book, 2.5 starts at page 99. If you want to follow along, because there's those notes in the student journal, this will be pertinent on pages 56 to 58. And I also expect you to have either my blank notes on the screen and you're writing them down, or print them and fill them in as we go. So let's start. So as you can see, a proof is a logical argument that uses deductive reasoning to show that a statement is true. And so in a two-column proof, the statement is always on the left. The reason is always on the right. That's just how we do it. And here's an example of this problem was done in the last section, but we're going to show how to do it as a proof. So,
write a two-column proof for the situation in example 4 from the section 2-4 lesson. In the example you were given, the measure of angle 1 is equal to the measure of angle 3, and you need to prove the measure of angle DBA is equal to the measure of angle EBC. A two-column proof has numbered statements and corresponding reasons that show an argument in a logical order. To create a two-column proof, label the left column statement and the right column reasons. Each statement in the left-hand column is either given information or the result of applying a known property or fact to statements already made. Each reason in the right-hand column is the explanation for the corresponding statement. Start with the given information. You are given the measure of angle 1 is equal to the measure of angle 3. Next, using the angle addition postulate, the measure of angle DBA is equal to the measure of angle 3 plus the measure of angle 2. Because the measure of angle 1 is equal to the measure of angle 3, you can use the substitution property of equality to substitute the measure of angle 1 for the measure of angle 3 in the second statement. This gives you the measure of angle DBA is equal to the measure of angle 1 plus the measure of angle 2. Refer back to the diagram. Using the angle addition postulate, the measure of angle 1 plus the measure of angle 2 is equal to the measure of angle EBC. Because the measure of angle DBA is equal to the measure of angle 1 plus the measure of angle 2, and the measure of angle 1 plus the measure of angle 2 is equal to the measure of angle EBC, then by the transitive property of equality, the measure of angle DBA is equal to the measure of angle EBC.
now as you're going along these, what I'd really like you to do is maybe, if I was able to draw on the screen here, like highlight with different colors what you know is the same. For instance, 1 and 3 is the same, so I might highlight them both in yellow or both in blue. And that'll really help you see what's going on as we're doing examples. So what we're going to do is talk about these theorems. You can use definitions, properties, postulates, and theorems that we've used before. It's a statement that can be proven, as opposed to a postulate, which we just accept to be true. But once you prove that theorem, then you can use that theorem throughout the rest of the year. So here are properties of segment congruence, and they're called Theorem 2.1. These are almost what we wrote in the notes, but as you can see, we have reflexive, symmetric, and transitive properties, but now they're in a theorem. We also have properties of angle congruence and the same reflexive, symmetric, transitive. So you can now use those in your proofs. Now what we're going to do is name a few of them for a few minutes here. So I'm going to go ahead and press play again.
Name the property that the statement illustrates. Part A. If angle T is congruent to angle V, and angle V is congruent to angle R, then angle T is congruent to angle R. Part B. If segment JL is congruent to segment YZ, then segment YZ is congruent to segment JL.
So before I put the solution up, think about this for a second. Which property says that if these angles are congruent, then we can say angle T is congruent to angle R? And this is important, this think time. Some of you may have it already. If you don't have it yet, think about it for another 10 seconds. This one is also, when you look at what's the difference between here and here, that property is that we swapped them out. And we talked about that the other day. That is, well, I'll just put it on.
Solution. In part A, the statement shows that an angle is congruent to a second angle, and that second angle is congruent to a third angle, so the first angle is congruent to the third angle. When you look at the list of properties of angle congruence, you can see that this statement resembles the transitive property of angle congruence. Therefore, the statement, if angle T is congruent to angle V, and angle V is congruent to angle R, then angle T is congruent to angle R, illustrates the property of transitive property of angle congruence. In part B, the statement shows that the first line segment is congruent to the second line segment, so the second line segment is congruent to the first line segment. When you look at the list of properties of segment congruence, you can see that this statement resembles the symmetric property of segment congruence. Therefore, the statement, if segment JL is congruent to segment YZ, then segment YZ is congruent to JL, illustrates the symmetric property of segment congruence.
Now, as we're going along here, you know you don't have to write it all out like this. We already talked about what kind of abbreviations are acceptable. But we are going to go and do another one. This is in your notes, so find where it is, and you can copy it down or pause as much as you need. But we're going to, when writing a proof, organize your reasoning by copying or drawing a diagram for the situation described. So if you don't get it, get the picture, draw it. Otherwise, you should always just start with a little T chart, put statements and reasons, and let's go.
Write a two-column proof for the symmetric property of segment congruence. When writing a proof, organize your reasoning by copying or drawing a diagram for the situation described, then identify the given and prove statements. The symmetric property of segment congruence states, if segment LM is congruent to segment NP, then segment NP is congruent to segment LM. So draw a diagram where segment LM is congruent to segment NP, as shown. So the given statement is segment LM is congruent to segment NP. You want to prove that segment NP is congruent to segment LM. Create a two-column proof with statements on the left and reasons on the right. First, start with the given statement. Segment LM is congruent to segment NP. Recall that congruent segments have the same length. So by the definition of congruent segments, LM is equal to NP. Then by the symmetric property of equality, NP is equal to LM, which means the line segments NP and LM have the same length. So by the definition of congruent segments, line segment NP is congruent to line segment LM.
So that's your first geometric proof. Here's another example, but this is about the property of midpoints. So you have to think about the definition and what the definition gives you. So if you get a midpoint, that'll give you two equal distances. And if you get two equal distances, then half of them is going to be equal. So you should always try to figure it out like mentally before you write anything down. Here's our last example.
Prove this property of midpoints. If you know that M is the midpoint of segment AB, prove that AB is 2 times AM and AM is 1/2 AB. Draw a diagram for the situation described. Draw line segment AB with a midpoint M. You are given M is the midpoint of line segment AB, and you want to prove AB equals 2 times AM and AM equals 1/2 AB. Create a 2-column proof with statements on the left and reasons on the right. Start with the given statement. M is the midpoint of line segment AB. A midpoint of a segment divides the segment into 2 congruent segments, as shown in the diagram. So by the definition of midpoint, line segment AM is congruent to line segment MB. Line segments that are congruent have the same length. So by the definition of congruent segments, AM is equal to MB. By the segment addition postulate, AM plus MB is equal to AB. Then you can use the substitution property of equality to substitute AM for MB in statement 4. So AM plus AM is equal to AB. Then use the distributive property to combine like terms, which gives you 2AM equals AB. Use the division property of equality to divide both sides of the equation by 2, which gives you AM equals 1/2 AB.
So hopefully all of these steps make sense, and ask questions if they do not. What we're going to do is we're going to go over these properties of congruence more in class, but for now I'm going to stop this part and we will continue in another video.